All right, so I've had a couple questions about creating a frequency chart for quantitative variable, basically creating the bins or the width of the bins and all that stuff. So let's go ahead and look at the beer data that we had been looking at a few classes ago. So in particular, I want to do a frequency chart for calories in a 12-ounce beer, so column D. So I'm going to go ahead and go over to a new worksheet and make this a bit bigger. So there's two ways that we're going to do this. Both of them I need to know pretty much the max and the min. So I want the max, the biggest in the column D, and so I need to go down to up to 177. So D2 through D177, I'm going to hit F4 and make my life a little bit easier. So the maximum calories in our beer set is 330 calories for 12 ounces of beer. I'm going to just copy that down and change max to min here. All right, so the smallest is 55 calories. So there are two ways that we looked at this. One was to first create the number of bins that we want and then calculate an approximate width from that and go from there. The other way is just to decide on a width category and go with the width. Maybe what I'll do is I'll do the width first. So how wide do I want each of the buckets or bins or categories? So we could do 50 calories. If we do that, then that's probably going to be pretty big. The first bin, I always use the minimum, so 55. And then for the next bin, I take the minimum, which was the 55, and I add to it how wide I want the bin to be. And I hit F4 for that one. So this one we're not going to have, we would go up to here. So we would have a total of 1, 2, 3, 4, 5, 6, 7 bins. Which, I don't know, maybe that's not enough, but let's try it and see what it looks like. And now the tricky part that some people stumble on is coming up with the frequencies, so the count that falls into each category. For this, we do one more than where our bin array is going to be. All right, so all we did for the width is just simply to find the bin arrays. And then once I select those cells, I hit equal frequency. And the data array is over on sheet 1, which I can reference by giving its name, exclamation mark. And we said it was in D2 through D177. The bins array are what we just calculated, so those 6 rows, 55 through 305. Close parenthesis, and do not hit enter here. Instead, it's an array formula. So for array formulas, you have to hold down the control key, hit the shift key, and then hit enter. And then it counts the number in each bucket. This is more. Once we have this, then we can insert a column chart. Looks like this. And if we want to make it pretty, we can format the data series and get rid of the gap width altogether to make it look like some kind of contiguous distribution. I'd probably get rid of grid lines as well. All right. And then probably what we should do is also edit this to be the bins. Click OK. All right, so now I have the bin numbers down here. Yep. So this appears to be a right skewed distribution, the tail going out this way from this number of bins. So now if you change this, the width of the bin, right, it's going to look different. If we go down to 20, that's not going to be as good because notice I didn't. It's more than 155. Well, there's a bunch of them because there's a bunch of beers that are bigger than that. So doing the bin width, sometimes you need to make it a little bit wider, or the bin array a little bit longer. So that's a quick look at, this is calories. 12 ounces. All right, to see what the distribution looks like for this quantitative variable. And then the second way of doing it, I'm going to just go down a little bit further. I've got the max and min here. You pick the number of bins that you want. So let's pick 10. And then you get an approximate width. As a good starting point, we use the range, so max minus min in parentheses, divided by the number of bins. So 27 and a half. Right? So again, maybe we don't want the bins to be quite like that. We might want it to be a whole number, so we might round this up or down to 25 or up to 30 maybe. Yeah, so this is kind of an approximation. Let's go ahead and just leave it straight like that and go ahead and create the bins. Let's do bin and frequency here. And then again, the first bin is going to be the minimum, so 55. Then we take the one above it and add to it the width, anchor that, and scroll down to, alright, so I ought to be able to get rid of that. Usually go one less than what the maximum is. And then over in frequency again, I pick the number of rows plus 1 for the bin array, and I do equal frequency. And again, our data is in sheet 1, D2 through D177, and my bin array is this guy here. And again, I have to hit Control Shift Enter, and I get that. All right. So now I ought to be able to insert column, move it over, and again I can get rid of the gap width, select the data, edit the horizontal axis, the axis label to be these guys, click OK. Click OK. Right. So notice with a width of 50, we get a graph that looks like this. Of 27.5, we get something that looks like this. Which one's better? Well, it depends on what we're looking for. This one makes it look a little more symmetrical with a big bump right here in the middle. This one, it got that big bump in the middle, but it's slightly right skewed, it makes it look like. So, we'd have to do a little more investigation to see how it goes. Now, with the number of bins, what I could do is I can change it to, if I change it to 9, that pumps it up to about 30. And that looks quite different than the 27.5 for the width. Right? If I go up to 12, now we're going to get this big bump of more out here because, right, we're going bigger than 261. So again, different perceptions that you have by looking at it. So that's how you do a frequency chart with a quantitative variable.